Okay, so now let's look at this example here. Now we want to find the power series representation for this function, okay? Now the first thing you want to notice is that this is a product of two other functions. I mean, you could split this up as a product of two fractions, right? So you could write this as this, right? So it'll be the product of 1 over 1 minus x, right? Times the product, the quotient 1 over 1 minus x squared. Now, we know that we can write, there's a representation, right? There's a series representation for each of these. In fact, there's a power series representation for each of these, okay? So the power series representation for this one is equal to what? Well, this is going to be what? It's going to be n equals 0 to infinity of what? It's just going to be x to the n power, right? Okay? And this has an interval of convergence, so I'm just going to place, where do I want to do this? Okay, I'm just going to say it. So we know that this has an interval of convergence from -1 to +1. Okay? Now this one here, the power series representation for this one is going to be what? N equals 0 to infinity of what? It's going to be x squared to the nth power. Right? And this also has an interval of convergence from -1 to 1. Okay? Now, what else can I say? Okay, so what we can do is we can use the Cauchy product, right? So since we know what the common interval of convergence is for each of these, so it's -1 to 1, okay? We can use the Cauchy product for these two series to come up with a representation of this function. And again, we're looking at the interval of convergence of -1 to 1. Okay, well, how do we define E sub n? Remember, okay, so don't forget how we define E sub n. So that's going to be key here. Okay, so how do we represent this? So we know E sub n is we take the coefficient of this, which is 1, right? And so how is that going to help us? Oops. Well, in this case here, we need to multiply the two together. Okay, so how do we find E sub n in this case? Well, let's multiply these together, and what are we going to do? We're going to find the x sub n. Remember, it's going to be E sub n times x to the nth power, right? Okay, so what we're going to do is multiply these two series together. So let's review for a second here. So the first one, x sub n equals what? It's going to be, well, of course, this is x equals 0 to infinity. So this is going to be what? It's going to be 1 plus x squared plus x cubed, and on. And then the other one, n equals 0 to infinity of x squared to the nth power, well, what is that going to be? Well, that's going to be 1 plus x squared plus what? X to the 4th plus x to the 6th plus, and so on, right? Okay, so what we're going to have to do is we're going to have to multiply those together. Okay, so if we write out the first several terms, what's going to happen? Well, we're going to have to use the distributive property, right? So let's see what this thing is going to look like if we multiply these together. Okay, so again, we've got this, right, multiplied by this. So the way we could do it is we could distribute the 1 first across this. So what are we going to end up getting? So let's okay, so let's write this out. Just to see what it looks like. So the first thing we're going to do, we're going to do 1 times this whole thing. That's just going to give us 1 plus x squared plus x to the 4th plus x to the 6th, and so on. Okay, then we're going to say plus. Now we're going to multiply this whole thing by x. So we're going to take x, multiply this whole thing by x. Well, what do we get? Let's write that out. So we're going to basically multiply this whole thing by x. So all of these is going to go up by a power of 1 in x. So this is going to be x plus x cubed plus x to the 5th plus x to the 7th plus, and so on. And then we're going to add that to the next one. Now we're going to multiply this whole thing by x squared. So what happens now? Now we're going to get x squared plus what? X squared plus x to the 4th plus x to the 6th plus x to the 8th plus yada 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 plus, okay, now what else? Let's see here. Let's do one more. So if I do x to the 3rd times this whole thing, what do I get? I get x to the 3rd plus, well, x to the 5th, right? Plus x to the 7th plus x to the 9th plus dot dot dot. Okay, so now what can we do with these? So let's see, oh, by the way, then this keeps going plus dot dot dot. Okay, so again, this keeps going. Okay, so now what can we do with these? Well, let's see. Well, so here we've got 1 plus x squared plus x to the 4th, and then here we've got x. So what if we factor x here? If we factor out x here, let's see if that'll give us anything. Because in essence, what I'm doing is I'm factoring x, this will be a factor of x squared. Will that help us at all? Let me erase this. Do I want to erase? What do I erase? Do I want to erase anything? Okay, let me think. Let's erase this. Let me erase this. Okay, so I've got this because you guys have it in your notes. Okay, so I've got this so far. What I can do is, oops. Okay, so if I drop the parentheses, notice that I've got a 1 here and an x here, okay? Other than that, when I add these together, I've got, how many, okay, so I've got one of these, 1, 1, I've got 1x, and then what happens? I've got an x squared here, and an x squared here, and that's it, just 2 of those. And then I've got an x to the third here, and an x to the third there, and that's all I'm going to get. But then if I go to x to the fourth, I've got an x to the fourth here, I've got an x to the fourth here, and then I'm going to have another x to the fourth here. And then I'm going to have an x to the fifth, and then I'm going to have an x to the fifth, and I'll have another x to the fifth here. So what I'm going to end up is I'm going to have something like this. So I'm going to have 1 plus x, and then I'm going to have what? I'm going to have plus x squared plus x squared. Right, yep. And then I'm going to have plus x cubed plus x cubed. And then it's going to go to plus x to the fourth plus x to the fourth plus x to the fourth. And then it's going to be plus x to the fifth plus x to the fifth plus x to the fifth. And now, if you see the pattern, what are we going to get? We're going to get, it's going to keep going. It's going to go plus, and then it's going to go x to the sixth, but it's going to go to 4 times. Okay? And so this, let me rewrite this. So this is going to be 1 plus x plus 1 plus 1 x squared. Well, let me just skip it. So we already know, right? This is going to be 2 x squared plus 2 x cubed plus 3 x to the fourth plus 3 x to the fifth, and so on. Okay. So now, now we see okay. So now this is going to be the series and it keeps going like this. Now because of the series, we know that this has an interval of convergence, because these two series has an interval of convergence of -1 to 1. Now, I'm going to leave the series like this because we're not going to be able to write this as a series of E sub n, but again, we're using the theorem to come up with the series, because we know that both of these together is going to give us a sequence. So again, all we're doing is using how to multiply polynomials together, right? And to come up with this series. Now representing the series as e sub n times x to the nth, right? We can see that there's an x to the nth power, but it's not obvious how to write e sub n. Because what's going on, it starts at 1, 1, right? It's going 1, 1, 2, 2, 3, 3, and it's going to continue on 4, 4. How to write that as a e sub n, that's going to be a little difficult. Okay, so I would leave it as this. Again, if you came up with something like this, where it's not obvious how you can write that as a nice little e sub n, like we have in the past, just write it as a partial, right? And again, make sure you have your ellipse at the end showing that it goes on. And of course, your interval of convergence is here. That's it. Have a great day.